Okay, welcome once again, ladies and gentlemen, to part two of our review. We just ended with question number 8, so let us continue with question number 9. And if you missed part 1, please head over to part 1 where we go over some of the first questions. Remember, ladies and gentlemen, that in this review, I'm only going to be covering questions 1, 2, 3, 6, 8. Those 5 I did in the previous one, and in this specific video, I'm going to be doing questions numbers 9, 10, 11, 12, and 14. So let's go on with number 9. And number 9 simply reads, which inequality is true if t is equal to 6.8? In other words, wherever you see a t, instead of putting a t, you're going to put 6.8 and do that same operation. And in each of these, it's always multiplication. Remember, whenever you have a variable right next to a number, that means multiplication, right? So for example, in A, I would do 27.2 is less than or equal to 7.8 times 6.8. So in other words, ladies and gentlemen, it's basically asking, is this a true statement? That when I multiply these two, whatever you have on this right side is going to be greater than or the exact same thing as 27.2. So let's go ahead and work this out. We have 7 and 8 tenths times 6 and 8 tenths. And let's go ahead and multiply this together. 8 times 8 is 64. 8 times 7 is 56 plus 6 is 62. We're done here. We're done with this column. Now 6 times 8 is 48. And 6 times 7 is 42 plus 4 is 46. We add these together. We get 4, 10, 13, and 5. We have 2 decimal places, so it would be 53 and 4 tenths. So is 27 and 2 tenths less than or equal to 53 and 4 tenths? 400ths, sorry. Yes, 56 and 400ths is definitely greater than, even though it's not equal to 27.2. So ladies and gentlemen, A would definitely be a right answer. The problem with this question though is that you're gonna find that there's another right answer. Don't worry so much about that, just as long as you understand that whenever it tells you, hey, is this true? When t is equal to 6.8, you just have to substitute it in there. So just as I put 6.8 instead of t for letter A, you would do the same thing for B, for C, and for D to see which of those is a true statement. Moving on to number 9. Oh, sorry, number 10. This one is simply an inequality, ladies and gentlemen. This one is simply an inequality. Not an inequality. This is a order of operations. Order of operations. Which, when we do order of operations, again, like we did earlier, we have to remember PEMDAS. PEMDAS, which tells us to first worry about the parentheses, followed by the exponents, or when we're inside the parentheses, do exponents, multiplication and division, right? Remember, those two are together, and then addition and subtraction, again, those two are together. All right, so let's look at the parentheses and notice that inside the parentheses, I have multiple operations. I have exponents, I have subtraction, and I have multiplication. Well, guess what? We still have to do PEMDAS. So I'm going to start out with 4 to the second power. Now, please remember exponents. That means that there are 2 number 4s. That's what that 2 means, that are being multiplied together. So 4 times 4, that's 16. So therefore, what I have left over is this. I'm just going to rewrite everything. 3 times 2 minus 2 parentheses. Instead of a 4 squared, I'm going to write the answer to that, which is 16, minus 5 times 2. Close parentheses. And let's continue from there. Notice that I'm still not done with what's inside the parentheses. So I have to either subtract or multiply. According to PEMDAS, I always multiply before I subtract. So I'm going to do 5 times 2. 5 times 2 is 10. Bring everything else down. Very good. All right, let's continue. Again, I'm still not done with the parentheses, but now I only have one operation in there. That is 16 minus 10, which gives us 6. Bring down the parentheses. Some of you might ask, well, Mr. Lugo, didn't you have a parentheses over here with the 3 times 2? No, guys, because remember, we look at what is inside the parentheses. And 2 is just 2, and it's right next to the 3. That just means multiplication, all right? So that's why I did the parentheses over here first. Now notice this. I have multiplication, I have subtraction, and then I have multiplication. Ladies and gentlemen, in this case, multiplication always comes before subtraction. I'm just going to do the one that comes first. So 3 times 2. It's going to be 6 minus whatever 2 times 6 is. And 2 times 6 is 12. So I just have 6 minus 12. Now, remember, this is not 12 minus 6. It's 6 minus 12, meaning that if I had a number line and I had 6, 1, 2, 3, 4, 5, 6, I'm going to take away 12 from that. But what happens once I take 1, 2, 3, 4, 5, 6? I'm already at 0. Well, guess what? I have to keep going. So that's going to be -1, -2, -3, -4, -5. It's going to take me all the way down to -6 because I took away 12 from there, right? So 6 minus 12. So that would take me down to -6. Another way to do that, ladies and gentlemen, is to remember the acronym KCC. Keep, change, change. Remember, we do KCC whenever we're subtracting and we're taking away more than what we have, or I'm subtracting with negative numbers. So I'm going to keep the 6, change subtraction to addition, and then change the second number into a negative number because it's positive, so I'm going to change it to negative. 6 plus -12. Even though I am adding, they're going in different directions. So I'm actually going to be subtracting, right? So 12 minus 6 is 6, and we have more negatives than we have positives. Ladies and gentlemen, the answer is -6. We only ask if there are more negatives than positives if we're adding, ladies and gentlemen. That's the only time we ask, are there more negatives than positives or more positives than negatives? Only when we're adding, we have different signs. Please review the rules for adding and subtracting integers if you're confused about that. But yes, the answer would be B, which is -6. Very good. Moving on. And again, if you didn't catch all that, go back, pause it, and then you can copy all of that. Let's go on to number 11, ladies and gentlemen. Numbers 11. Sophia has $72. $72 after her grandma gave her $15 for her birthday. So she starts with a certain amount. Her grandma gives her 15, and then now she has $72, right? We want to know which equation can be used to find X, the amount of money she had before getting money for her grandma. So again, so she had a certain amount of money. Then her grandma comes and gives her 15 bucks for her birthday. Now she has $72. All right. Obviously, the answer is B. That's the only one that matches this. I'm not multiplying anything. I'm not dividing anything. And I'm not subtracting anything. I would subtract to solve it, but this is what makes sense. Okay. Moving on. 12. Which expression is equivalent to 5 plus parentheses 2 times x? It's interesting that they put 2 times x inside the parentheses because even without the parentheses, ladies and gentlemen, if I follow the order of operations, I can see that I would still have to do the multiplication first. But regardless, let's see which one over here do they have us multiplying 2 and x and then adding 5 to that. So notice that A, yes, they have us multiplying 2 and x right here, but they have us subtracting 5. So that doesn't help. B, they have us here multiplying 2 and x. And notice that all they did is they switched them around. But remember, multiplication and addition, they are commutative, meaning the order doesn't matter. 2 times x is the same thing as x times 2. Good. And then they add 5. They add 5. It's the exact same thing as that what I have right here. I'll put that as a maybe. Over here, they have addition and multiplication. I would have to multiply 5 times x first, which is not what I have up here. So that is clearly wrong. And over here, they're having us add x and 2 first, which again is not what I have over here. So the only one that makes sense is B. Awesome. Finally, ladies and gentlemen, we have number 14. We'll do number 13 tomorrow. It says a chain has links that measure 1.2 centimeters each. 1.2 centimeters each. So we're going to have several links. I don't know how many, but it's going to have all of these links. And we know that each of those links making up this chain, just going to keep going. Each of those links is 1.2 centimeters, and it's going to keep on going. 1.2 centimeters, and the chain keeps on going. How many links are there on a chain that is 15.6 centimeters long? In other words, if the full length of the chain was 15.6, how many of these little links do I need? Ladies and gentlemen, what am I doing when I am taking that chain and I'm splitting it into sections that are 1.2 centimeters long? They're all the same length, right? So I'm splitting it into equal lengths, equal sizes. That's division. That is literally the definition of division. Taking something and then splitting it into equal sizes. So I'm going to do 15 and 6 tenths divided into lengths that are 1.2. Now remember, we do not like decimals on the outside, so I'm going to move it over to the inside to make it into a whole number. And I have to do the same thing with this decimal over here. All right, so that's the same thing as doing 156 divided by 12. If you don't know how I did that, you need to review um, how to divide with decimals, ladies and gentlemen. That is something that we did the first month of school. All right, 12 goes into 1 0 times, but it goes into 15 once. So it's going to be 12. We have a remainder of 3. Bring down the 6. And 12 goes into 36 exactly 3 times because 12 times 3 is 36. Ladies and gentlemen, there's going to be 13 links exactly. That is it, guys. Don't just worry about the answer, okay? Do not worry about the answer as much as understanding how I got the answer. Okay, if you find that you're struggling with dividing decimals, if you find that you're struggling with the order of operation, PEMDAS, ladies and gentlemen, please, please, please take advantage of the resources that I have on Schoology. Go back to Schoology, go to resources, which is the green folder, and watch, division review, simplifying fractions. I have one on exponents. Any of these things. Order of operations, number 23 is a big one that we did we not? Obviously, not every lesson is on here, but some of the more notable ones is dividing fractions, adding integers, subtracting integers. That's a huge one. Multiplying integers, dividing integers. Anything and everything, ladies and gentlemen, is there for you to get ready for this test. Now, lastly, do not stress too much about this test. Just try your best. Um, show your work, take your time. That's pretty much it. Tomorrow, we'll continue reviewing the rest of the questions that we didn't look at today. And I will see you soon.